हेलो दोस्तों, स्वागत है आपका डीयू फिजिक्स एग्जाम प्रेप बाय विनय प्रताप। इस चैनल पर आपको मिलेगा डीयू एमएससी फिजिक्स से रिलेटेड कंटेंट। इस वीडियो में हम सॉल्व करेंगे क्वांटम मैकेनिक्स 2 ट्यूटोरियल 7। अगर आपको बाकी सब्जेक्ट्स के भी ट्यूटोरियल सॉल्यूशन अलोंग विद पीवाईक्यू सॉल्यूशन चाहिए तो आप इस चैनल को सब्सक्राइब कर सकते हैं। एंड अगर आप मेरे प्लेलिस्ट सेक्शन में जाएंगे तो वहां पर आपको सॉलिड स्टेट फिजिक्स, उसके ट्यूटोरियल सॉल्यूशन एंड उसके पीवाईक्यू सॉल्यूशन। सिमिलरली फॉर ईएमटी के लिए आप लास्ट ईयर के डेरिवेशंस दे सकते हैं। इस साल में उसके सिर्फ पीवाईक्यू सोल्व कराऊंगा आपको, ठीक है। एंड अगर आप सॉलिड स्टेट फिजिक्स एंड ईएमटी एंड उसके बाद आपके पास क्वांटम मैकेनिक्स के ऑलरेडी मैं 6 ट्यूटोरियल सॉल्यूशंस अपलोड कर चुका हूं। दिस इज 7th ट्यूटोरियल एंड अलोंग विद पीवाईक्यू वीडियोस मैं इसके पीवाईक्यू सॉल्यूशन भी साथ साथ अपलोड कर रहा हूं। आपको जस्ट प्लेलिस्ट सेक्शन में जाना है, वहां से आप इजिली फाइंड आउट कर सकते हो। ओके, सो स्टार्ट करते हैं इस वीडियो को। सो क्वेश्चन नंबर 1 देखते हैं सबसे पहले। सो क्वेश्चन नंबर 1 इज थ्री आइडेंटिकल पार्टिकल्स आर इन वन डायमेंशनल हार्मोनिक ऑसिलेटर पोटेंशियल वेल with classical angular frequency omega. Write the complete time independent Hamiltonian for this system. So you have to write time independent Hamiltonian for this system. And system क्या है हमारे पास? एक वन डायमेंशनल हार्मोनिक ऑसिलेटर है, पोटेंशियल वेल है, उसके अंदर आपके पास थ्री आइडेंटिकल पार्टिकल्स हैं, ठीक है। सो यू हैव टू फर्स्ट ऑफ ऑल यू हैव टू राइट द टाइम इंडिपेंडेंट हैमिल्टोनियन एंड एक्सप्रेस इट इन कोऑर्डिनेट स्पेस एज अ डिफरेंशियल इक्वेशन हुज सॉल्यूशन इज थ्री बॉडी वेव फंक्शन। एंड बेसिकली हमको उसको डिफरेंशियल इक्वेशन की फॉर्म में रिप्रेजेंट करना है। सो फॉर नॉन इंटरेक्टिंग पार्टिकल्स द टोटल एनर्जी इज द सम ऑफ इंडिविजुअल एनर्जीज। फॉर एग्जांपल आपके पास थ्री पार्टिकल्स हैं, सो द टोटल एनर्जी ऑफ दिस सिस्टम will be the individual sum of energies of individual particles. Okay, so how you will write the total Hamiltonian? So total Hamiltonian, let's represent it by H. Okay, so total Hamiltonian is summation over all particles, summation from I is equals to 1 to I is equals to 3, and here we will write the Hamiltonian. So Hamiltonian is minus h cut square divided by 2m del square by del xi square. Okay, where xi is the position of your ith particle, and then we will have the potential term. So potential term for the harmonic oscillator potential is half m omega square and xi square. Okay, so this is the Hamiltonian for such a system. Now we have to represent our Hamiltonian in terms of space coordinates. Okay, so we will simply expand this and we will write the Hamiltonian energy, Hamiltonian operating over your system psi will give you the energy and then the wave function. So कैसे लिखेंगे इसको देखो, minus h cut square divide by 2m and let's write del square divide by del x1 square plus del square divide by del x2 square plus del square divided by del x3 square, ठीक है। Now let's write the second term. So second term will be half m omega square is common. Then we have x1 square plus x2 square plus x3 square. Okay. This is Hamiltonian. When this Hamiltonian will operate on my wave function. So wave function is simply psi as a function of x2, x1, x2, x3. Okay, space coordinates. So what does it will give me? It will give me the energy. So let's say energy is E, and then I will get the wave function. Okay, x1, x2, x3. So this is the Hamiltonian for this system. Fine. So this is answer to your part A. Now let's look at part B. Assume the particle has zero spin. Use the single particle wave function to construct the ground state wave function and show that it satisfies the differential equation in A and find out the ground state energy. So now these three identical particles have spin 0, and you can say these particles are bosons because bosons have 0 spin. Okay, so we have to write the individual wave function of each of these boson, and with the help of that wave function we have to construct the ground state wave function for this complete system, and we have to show that it satisfies the differential equation. Okay, so let's do it. So in part B, since particle with zero spins are bosons, okay, identical bosons are described by the total wave function for bosons is symmetric. Okay, and in the ground state they are not restricted by Pauli exclusion principle. Pauli exclusion principle हमारे पास क्या कहता है कि अगर आपके पास identical particles हैं, okay, and they are fermions. Pauli exclusion principle is basically for fermions, identical fermions. Pauli exclusion principle. Pauli exclusion principle. So these bosons which have zero spin, they do not follow Pauli exclusion principle. They do not follow simply. Okay, so the total wave function for bosons will be symmetric, and it means there is no restriction कि आप ग्राउंड स्टेट में कितने बोसोन्स को प्लेस करोगे. फॉर एग्जांपल आपके पास अगर पोली एक्सक्लूजन प्रिंसिपल फॉलो हो रहा होता तो आप क्या कर सकते हो, ग्राउंड स्टेट में सिर्फ मैक्सिमम दो पार्टिकल्स को प्लेस कर सकते हो अलोंग विद देयर अपोजिट स्पिन्स. उनके जो चार डिफरेंट क्वांटम नंबर्स होते हैं वो डिफरेंट होने चाहिए. पोली एक्सक्लूजन प्रिंसिपल के अकॉर्डिंग आप दो इलेक्ट्रॉन्स को प्लेस कर सकते हो, दो पार्टिकल्स को, बट दे शुड हैव अपोजिट स्पिन्स. But since these identical particles are bosons, so they do not follow Pauli exclusion principle. It means in the ground state you can put as many bosons as in the ground state. Okay, and ground state for harmonic oscillator, the ground state is n is equals to 0. Okay, and the energy of the harmonic oscillator is given by En is equal to n plus 1 by 2 h cross omega. ठीक है, this is the energy of harmonic oscillator where n can vary from 0, 1, 2, 3 and so on. Fine. So n is equals to 0 will give me half h cut omega. Fine. Now let's write the single particle ground state wave function. Single particle ग्राउंड स्टेट वेव फंक्शन. एंड इसका क्या होता है, हार्मोनिक ऑसिलेटर के पोटेंशियल के केस में इट इज रिप्रेजेंटेड बाय phi 0 ऑफ x एंड इट इज इक्वल टू m ओमेगा डिवाइड बाय pi h क्रॉस पावर 1 by 4, and then I have an exponential term in minus m omega x square divided by 2h cross. So this is the ground state wave function for single particle, or you can say boson in your harmonic oscillator, and this is the energy. This is the wave function and this is energy. Okay, so and single particle energy is this in ground state. So you can write single particle ground state energy. It is represented by E0 where n is equals to 0 and it is simply equal to half h cut omega. Fine. Okay, now let's write for three bosons. This I have written for single particle. Now we will write for three identical bosons. The ground state wave function will be simply the product of single particle ground state. What does it mean? कि जो आपका total wave function होगा three bosons के लिए, which is a function of x1, x2, x3, it will simply be the product of individual boson wave function. For example, this is my wave function for first boson. Then the complete wave function will be product of wave function of individual bosons. So phi 0 of x3. Okay, and if you multiply phi 0 x1, so you will change x1 here and x2 x3. Only this term will change, this will remain same. So it will become m omega by pi h cross power 3 by 4, and in exponential you will have exponential minus m omega divided by 2h cross, and then you have x1 square plus x2 square plus x3 square. Okay, and the complete energy, you can say energy of this system will be simply H operator Hamiltonian operating over your ground state wave function x1, x2, x3. So what does it will give me? Individual Hamiltonian of single bosons operating over your individual wave functions, that is phi 0 x1, phi 0 x2 and then phi 0 x3. Okay, so when this individual Hamiltonian will operate on individual ground state wave function, it will give me energy E0, similarly from second Hamiltonian and from third Hamiltonian. Okay, so energy will be simply, if you write this is, and you will get the same wave function, that is the ground state wave function. Okay, so this term is known as your E of ground state, means the energy of ground state, and it is simply equal to 3 into half h cut omega. So you can write 3 by 2 h cut omega. Okay, and this is the ground total wave function for bosons. Fine. Now let's look at part C. In part C, assume that the particles have half integer spin. Now the spin of the particles have been changed to half. With angular momentum j is equals to half, repeat B, means you have to write the single particle wave function, and then you have to write the total wave function and show that it satisfies the differential equation in A. So कैसे करेंगे इसको, देखो. So for part C, now for particles with spin half or particles with j is equals to 1 by 2, they are basically your fermions. Okay, and for fermions, they must satisfy the Pauli exclusion principle. And what does Pauli exclusion principle says? It means in ground state you can have at max 2 fermions with opposite spin. Okay, or in other words, you can say no 2 fermions can occupy same state. No 2 fermions can occupy same state. Okay, this is your Pauli exclusion principle. Right, now how you will write the single particle wave function? So let's start filling up the, first of all, the particles, and we will start filling up from the bottom. In bottom you will have ground state, then you will have n is equals to 1 state. This is first state, first excited state. Then we have n is equals to 2. So you will start filling up the particles from the bottom, that is the particles level which have minimum energy. So in n is equals to 0, you will have how much particles? 2 particles, or you can say 2 fermions, and they will have opposite spins. In n is equals to 1, you will have 1 particle. You can put either in up spin or down spin. So in total we have 3 particles. So this is how the configuration will look like. Okay, so now first of all, let's write the total energy of this configuration. So E total will be simply equal to, if you see there are 2 particles. So 2 particles in ground state. So ground state have energy half h cut omega plus 1 particle in first excited state, and first excited state had energy 1 plus 1 by 2, it means 3 by 2 h cut omega. So now if you add these two terms, so 1 plus 3 by 2 is simply 5 by 2 h cut omega. So this is the total energy. And again I have written here, this is the energy of any level and any nth value of harmonic oscillator. So if you put n is equals to 1 here, you will get 3 by 2 h cut omega. Fine. Now let's we have written the energy. Now let's write the wave function. So the total wave function must be antisymmetric for fermions. So let me add first page there. Yes. So the total wave function must be antisymmetric. Must be antisymmetric. Okay. And we know that the total wave function can be written in two parts. Total wave function can be written in two parts. That is the spatial part of the wave function, and then you can say the spin part of the wave function. So your total wave function is always it always comprises of two parts. That is spatial wave function and then spin wave function. So let's particle by particle, let's write the wave function. So for particle 1, that is the particle in the ground state, I'm taking one of these particles. So for particle 1, which is in n is equals to 0 state, okay, and it has spin up, this is the spin of the particle. So its wave function will be given by u1 of x, and it will be simply phi 0, that is the spatial part, into the spin part, and spin part, let's write it like this. Okay, so this state represents spin up. Fine. Now let's similarly write for particle 2. So for particle 2, which is also in n is equals to 0 state, but it has downspin, so its wave function will be represented by u2x, which has ground state wave function phi 0x, and then it has downspin. So this state represents the downspin. Similarly, let's write for particle 3, which is in n is equals to 1 state. Phi 0 is the wave function for the n is equals to 0 state, or you can say ground state wave function. Let's say it has either upspin or downspin. Okay, so and its wave function will be given by u3x. So it will be simply phi 1 of x, where phi 1 of x represents the spatial part of this particle 3 in first excited state. And you can have two possible wave function here, either with spin up, or you can write phi 1x with downspin. Fine. So both are correct. But even if you write one of them, then it is correct. Okay, so now let's write the full ground state wave function. This is the individual wave function of single particle. Now let's write the total wave function. So the total wave function will be, again psi 0 for particle x1, x2, x3. So it is it is given by the Slater determinant. And हम Slater determinant कैसे लिखते हैं? 1 over root n factorial, where n is number of particles. So number of particle here is 3. So 1 by 3 factorial, and then we put a determinant. Okay, then we put a determinant, and in the determinant here we write u1, that is wave function of particle 1 with state 1, it is in state 1, and then we write u2, a wave function of particle 2 in state 1, and then for similarly for third particle, then similarly we write u1 in state 2. Okay, and then similarly you write u3, sorry, not u3, u1, u2, and then you have u3. एंड इसको अगर आपको फाई की फॉर्म में लिखना है तो आप कैसे लिखोगे? सिंपली 1 by root 3 is simply 1 by root of 6. 3 factorial is root 6. And then we will write simply that phi 0 x1, ऐसे आपको लिखना है कि 1 represents spin up state. Similarly you have, this is for particle 1. अब देखो particle 1 हमारा हमेशा कहाँ पे था? ग्राउंड स्टेट वेव फंक्शन में था. सो यू विल राइट phi 0 x1 with down spin, and then particle in the first excited state, and then you will write x1. Here I'm only writing the up part. ठीक है, you can also write for down state. So आपके पास आएगा phi 0 x2 with spin up, then phi 0 x2 spin down, and then phi 1 x2 with spin up, and then similarly phi 0 x3 spin up, phi 0 x3 spin down, and then phi 1 x3 spin up. फाइन, थोड़ा सा यहाँ पे ध्यान देना, ये आपका क्या हो गया, स्लैटर डिटर्मिनेंट, एंड ये जो लेफ्ट हैंड साइड में ये क्या आपका टोटल वेव फंक्शन फॉर दिस सिस्टम. फाइन, सो आई होप आपको क्वेश्चन अच्छे से समझ आया होगा. आई हैव एक्सप्लेन्ड ऑल दी पार्ट्स ए बी एंड सी. So now let's move on to next question. So next question is question number 2. Consider three particles, identical particles, in a box of length A and calculate the ground state energy with considering the particle as distinguishable. So you have to consider first of all as distinguishable particles. So this is part 1. Then we will calculate assuming the particles are bosons, and then we will assume that the particles are fermions. So for three different particles, we have to calculate the ground state energy. And in part B, we have to write the corresponding three body wave function in all these three cases. So for three particles in a one-dimensional square well, the single particle energy and eigenfunction and eigenvalue are given by, that is, the single particle. Remember, this is for one-dimensional infinite square well. One-dimensional infinite square well. This is not a harmonic oscillator potential. This is for one-dimensional infinite square well. We will write the ground state energy and then corresponding wave function. So the single particle eigenfunction and eigenvalues for a box of length A is given by कैसे लिखेंगे इसका फंक्शन, phi n as a function of x is equal to root 2 by a sin n pi x by a, sin n pi x by a, where a is the length of your potential well. You can write L also if length is L, but we are given that the length is A, so we are writing A. Okay, and the energy is simply En. So En is equal to n square pi square h cut square divided by 2ma square. ठीक है, where n is equals to 1, 2, 3, 4. Remember, in previous question we have seen that n will start from n is equals to 0, but in the case of one dimensional infinite square well, n will start from 1. Okay, so keep remember this thing. So this is the wave function and this is the energy. Fine. So now let's write for first. Let's assume that the particles are distinguishable particles. So first of all, I am assuming that the particles are distinguishable. Distinguishable particles. So again, distinguishable particles do not follow Pauli exclusion principle. Okay, so all these particles, all these three particles you can put in the ground state. So all these, let me write. So all three particles can occupy the ground state. And the ground state. and if this that ground state means n is equals to 1, remember n is equals to 0 is not the case here, and for such a case the ground state energy will be simply, you have to put for three different particles n is equals to 1. So it will be simply, for first particle it will be even, for second particle it will also be even, and for third particle it will be even. So if you put n is equals to 1 three times here, so it will be simply 1 square plus 1 square plus 1 square, and you take these term common, that is pi square h cut square divided by 2ma square. So your total energy will be simply 3 times 1 plus 1 plus 1 will become 3, 3 times pi square h cut square divided by 2ma square. So this is the ground state energy. Ground state energy if you assume that the particles are distinguishable. Now let's assume that the particles are bosons. Okay, so what will happen if you assume that the particles are bosons? Similarly, for bosons, bosons do not follow Pauli exclusion principle. So you can also put the bosons, all three bosons in the ground state. So it will be same for bosons also, that the ground state energy will be same, that is 3 pi square h cut square divided by 2ma square, and the reason is same, that they also do not follow Pauli exclusion principle. Similarly, now if you assume that these three particles are fermions and without spin, remember that the particles are fermions without spin. So fermions must satisfy the Pauli exclusion principle. Since we are ignoring spin, so each level can hold only one particle. If अगर क्वेश्चन में हमें गिवन होता दैट स्पिन, दे फर्मियोन्स हैव स्पिन, सो यू कैन पुट, अगर आपके पास ऐसे गिवन होता कि आपके पास फर्मियोन्स है बट यू कैन हैव स्पिन ऑल्सो, स्पिन ऑफ फर्मियोन्स ऑल्सो, देन यू कैन पुट two particles in the same level. But since we are given that there is no spin exist for fermions, so you can only put, now the limitation is that you can only put one particle, you cannot put another particle with opposite spin. So either you can put particle with up spin or you can put particle with down spin. Okay, so in this case, so E total, that is the ground state energy, ground state energy, so E total will be simply, so you have to put, now कैसे पुट करेंगे हम इन तीन फर्मियोन्स को, देखो अब आपके पास लिमिटेशन है कि ग्राउंड स्टेट के अंदर आप एक ही पार्टिकल पुट कर सकते हैं, ठीक है। सिमिलरली जो आप सेकंड पार्टिकल को प्लेस करोगे वो आपको सेकंड एक्साइटेड स्टेट में पुट करना पड़ेगा। सो नॉट सॉरी सेकंड, इट इज फर्स्ट एक्साइटेड स्टेट, फर्स्ट एक्साइटेड स्टेट, n इज इक्वल टू 1 इज द ग्राउंड स्टेट। सिमिलरली अगेन आपके पास लिमिटेशन है कि इनकी स्पिन नहीं है तो आप एक ही पार्टिकल पुट कर सकते हो n इज इक्वल टू 2 में। सो सिमिलरली योर थर्ड पार्टिकल विल बी प्लेस्ड इन सेकंड एक्साइटेड स्टेट। So the energy will be simply E1 plus E2 plus E3। even E2 कैसे लिखोगे, सिंपली 1 स्क्वायर, n is 2 here, so n 2 square plus 3 square, and then you have pi square h cut square divided by 2ma square. So if you add this, 3 square is 9, 2 square is 4, 9 plus 4 13 plus 1 14, and you have 2 in denominator, so 2 will cancel with 14, you will answer will be simply 7 pi square h cut square divided by 2ma square. Okay, so this is for fermions if you assume that these three particles are fermions. So this was part A, that we have to calculate the ground state energy. Now let's look at part B. Write the corresponding three body wave function in all these three cases. So three body wave function कैसे लिखेंगे? Three body wave function simply means you have to write the total wave function. So let me write here. Three body wave function means you have to write the total wave function. Okay, let's write here. So in part B, again you have to write in different cases. Let's say if the particles are distinguishable particles, in part 1, that is particles are indistinguishable particles. So the total wave function will be simply the product of individual wave function. So let's write this wave function by psi d. So let's say the wave function is psi d, where psi d just simply means that wave function for the distinguishable particles. And again it will be function of x1, x2, x3, and it will be simply phi 1 x1 and then phi 1 x2 and then phi 1 x3. Here I am not writing phi 0 just because n is equals to 0 level does not exist in one dimensional square well potential. Okay, and अगर आप यहाँ से आप इनका वेव फंक्शन लिखोगे तो इट विल बिकम √2/a क्यूब. सो इट विल बी 2/a एंड √2/a को मैं लिखता हूँ सिंपली पावर 3/2. ठीक है. सो फर्स्ट टर्म विल बी साइन, you have to put n is equals to 1. So it will be simply pi, x की जगह पे आप पुट करोगे x1 डिवाइड बाय a and then you will write sine pi x2 डिवाइड बाय a and then I will write sine pi x3 डिवाइड बाय a. This is the wave function for distinguishable particles. Now let's write for that if the particles are bosons. So again इसकी एनर्जी भी सेम थी एज इन केस ऑफ डिस्टिंग्विशेबल पार्टिकल, तो इसका वेव फंक्शन भी सेम होगा. अगेन आप शो कर सकते हो कि बोसोन का आप वेव फंक्शन कैसे लिखोगे. दैट लेट्स राइट इट बाय psi b, where psi b represents simply for bosons. So it will result will remain same, that is 2/a power 3/2 into sine pi x1 by a into sine pi x2 by a, then you will write simply sine pi x3 by a. Okay, and now let's write for the fermions with zero spin. Fermions without spin. So let's represent this wave function by psi f as a function of x1, x2 and x3. Since these particles are fermions, so you have to write the wave function using your Slater determinant. That is, कैसे लिखते हैं Slater determinant? 1/√3 factorial, where 3 represents the number of particles, and then you have to write the determinant. I am simply writing the wave function. Okay, so phi 2 of x1, and then you have to write phi 1 x2 and then phi 2 x2 and then phi 3 x2, and then you will write phi 1 x3 phi 2 x3 and then phi 3 x3. Okay, so this is the complete wave function. So I hope guys आपको ये समझ आया होगा. I have tried my best to explain you. So thank you for watching this video. इस वीडियो में रखते हैं इतना ही. नेक्स्ट वीडियो में हम इसके बाद डिस्कस करेंगे क्वेश्चन नंबर 3 एंड क्वेश्चन नंबर 4 ऑफ ट्यूटोरियल 7. So thank you for watching this video and please do subscribe this channel for more videos related to MSc Physics. And अपने दोस्तों के साथ भी इसे शेयर कर देना. Okay, so मिलते हैं आपसे नेक्स्ट वीडियो में. बाय बाय, टेक केयर.